Hello, students. We are multiplying. Do you remember how to multiply? What does this look like? Today, we're going to use algebra tiles a lot, and we're going to remember things that we know. So if I want to multiply 2 times 3, I would just go like this. I would take 2, and I want 3 groups, okay? And then maybe you remember that if you have 3 groups of 2, you could organize it in a rectangle. So we know that 2 times 3 is 6. And the reason we know that is because that's what it means to multiply. Now, you could arrange 2 times 3 this way. And you have 2 groups of 3. Or you could do the same problem, but you could arrange the rectangle the other way. So I'm going to tidy up this space. And instead, I'm going to do 2 times 3 that way. The answer is still 6. So what that means is when we model multiplication, we can see it as a rectangle with side lengths 2 and 3. And the answer to this problem is 6. We can also see it as a rectangle as 2 times 3. The answer is 6. All right, what about 12 times 13? A lot of you learned to do 12 times 13. If you were taught in probably like a traditional method, teachers may have told you to do, they'd set it up like this. This is vertically set up. And then they would tell you 2 times 3 is 6, and then 3 times 1 is 3, and then randomly put a placeholder right here, and then move over and do 1 times 2 and do 1 times 1, and then you add it up and you get some number, okay? This is mostly just tricks. A better way to multiply 12 times 13 is to think about what each part is. You're still doing it the same way, but you just show it a little bit different. So you still do 3 times 2, which is 6. But this is where they start to lie to you. They said 3 times 1, but this 1 is in the tens place. So this is not 3 times 1. This is 3 times 10. And that's a little different. 3 times 10 is not 3. 3 times 10 is 30. And then they said 1 times 2. That's not right. That's lying to you. This is not 1. How much is this 1 worth? This is 10. 10 times 2 is 20. All right. And then what's this? This is not 1 times 1. This is 10 times 10. And how much is 10 times 10? 100. So it's a little bit different. You get the same exact answer. This is 150 and 6. But this way has a lot more understanding than just multiply, multiply, multiply. This may be shorter and faster, but this has so much more understanding in it. Okay, we can also think of 12 times 10, and this is the way that's going to help you with algebra. 12 times 13 as 10 and 2 and 10 and 3. These are 2-digit numbers. We could expand them into 10 plus 2 and 10 plus 3. Now, if you can understand what we're doing right now, then all the algebra today is going to be a piece of cake. Okay, so we're still thinking of multiplying. We're still thinking of an area model. So instead of just doing some random, procedural things, we can draw a picture of this. So I can draw a rectangle, and one side of my rectangle is going to be, one side of my rectangle is going to be 12. One side of my rectangle is going to be 12, and the other side of my rectangle is going to be 13. It's almost a square, isn't it? Not quite. Which side's longer? This side looks a little longer. So I'm going to put 10 plus 2 right here. And along the top, I'm going to do 10 plus 3. We're going to play with this kind of model a little bit more. And let me make it even better. 3 is not very big. And 2 is not very big. 2 is smaller than 3. Okay, so this is 10, and this is 2, and this is 10, and this is 3. So if I multiply 10 by 10, how many squares are in 10 by 10? That's 100. 10 times 10 is 100. Okay, how about 10 times 3? And some of you use these like models, right? These are 10 frames. Okay, 10 times 3, 10, 10, and 10 is a total of 30. How about 10 times 2 in here? 10 times 2, how much is that? It's 20. And how about this little corner right here? If I fill in these squares right here, I have 3 that direction and 2 that direction. How much is that? Well, that's 6. So what's the total answer here? Well, we had 100 because that was 10 times 10. We had 10 times 3 is 30. We had 10 times 2 is 20. And then we had 3 times 2 in the corner is 6. We're still doing 1, 2, 3, 4 math problems. And we're still doing the same 4 problems that you did here. The answer to this problem is the area that is covered by that rectangle with sides 10 plus 2 and 10 plus 3. So this is 100 plus 30 plus 20 plus 6 for a total of 156. I want you to keep this in mind. If you know how to multiply 2-digit numbers, you actually know how to multiply binomials, because if you have 2 pieces, it's a binomial. So we have an x plus a 2. That's just like if x was 10, that would be like 12. All right, so these are the algebra tiles. We're going to play with these. I already showed you the thing. This is an x. How much is this in algebra tiles? That's 6. How much is this? 1, 2. They're red. There's 3 of the x's that are red. So this is negative 3x. So this is kind of what the expression would look like with algebra tiles. This is a big fat square, right? It's a blue square, so this is an x squared. This way, if it was 10 times 10, this would represent 100. If it was 5 times 5, this would represent 25. It's a square, and then they're square numbers. Okay, how long is this? This is x plus 1. So we can draw it this way or this way. How about this one? We got an x and the 3, but they're negative. So this is x minus 3. And this one's kind of weird. We have a negative x with a positive x. All right, what's that? A number opposite and then the number. That's a 0 pair, we call that. This is a really important concept. Okay, basically, this is just a strange way in algebra tiles to build 0. This is 0. So those are some of the things we're going to use. Okay, so now we're going to go to our link and we're going to build a model of x plus 2 times x plus 3. So I'm going to tidy this space up, and I'm going to, when we do area model, we're going to set up a little workspace for ourselves. So we're going to set up, this is just going to represent the outside dimensions, and then the in here is going to represent our answer, the area. So we're trying to build, let's go back and look. We're trying to build one side of our rectangle with x plus 2 and one side with x plus 3. So I'm going to find an x and I'm going to grab it and I'm putting it kind of on the edge. You can also put it inside, but it's a little darker. It's kind of hard to see. So I'm going to put it on the outside. This represents x, and we want x plus 2. Now I could grab 2 over, or I could use the copy function. So there's x plus 2. Along the other side of our rectangle, we want x plus 3 because we're multiplying. We're multiplying these two things together. So we want to find out what the area is. So along the top, I'm going to put x, and then I'm going to copy x plus 3. So I have now built my problem. I've built x plus 2 times the quantity x plus 3. I don't think I can write on this. No, I can. Okay, so this is x plus 2, and this is x plus 3. Okay, now what? Now I want the answer. Where do we find the answer to a multiplication problem? It's in here. So what I'm going to do is I'm going to fill in each piece here. So x times x is perfectly filled in by this square. X times x is perfectly filled in by that square. So what we try to do is we try to fill in these places, and then once I've filled it in, then I know what my answer is. So this part right here is x times x. What is going to fit right here really nicely? Well, this is x times 1. So you can see I can fit right in here a perfect x. And then I can copy that over because 3 of them are going to fit really nicely. That would be too much. Okay. Oops. I'm learning my tool. I want to whoa. Now I'm causing problems. All right. There. Oh my. How does it know what I want to delete? Okay, it's a new tool for me too, so I'm just figuring everything out. So I don't want a tidy. Tidy would delete everything. I want another one of those, and I'm going to put my x times x back in, and I'm going to put x times 1. Okay, that fills in perfectly. What's going to fit down here? Well, an x is going to fit right there, and another one below it. How about this corner? Can I fit an x over there? No, it goes outside of the rectangle. That doesn't work. So I'm going to delete that one. So what does fit down here? Well, exactly these 6 constants fit down here. So using algebra tiles, we would build the outside of the rectangle of here's our x plus 2 and here's our x plus 3, and then we would fill it in. And after we fill it in, that's our answer. So I'm going to copy this and grab it over to the Jamboard. So we built it. It looks like this. And you can see the x plus 2 out here. And you can see the x plus 3 up at the top. And then this is our answer. Our answer is in here. Our answer is in here. So what do we have? If I want to know what the answer is, I need to look at all 4 of these, different pieces here. Let's go back to the algebra tiles. What I'm going to do is I'm going to delete these. There's a better way to do this. Okay, this is what I wanted. This was the answer. So what do I have? I have an x squared. I have a bunch of x's, and I have 6. So what we do is we take what we had and we combine the things that are alike. If I want to, I can rotate these. And then I can put them all next to each other. I can combine the things that are alike. And this is going to be my answer. Okay, this is what I had in the rectangle, and I'm just kind of rearranging it, putting them together. This is what was inside the rectangle, and this rearranged is my answer. So I'm going to take those pieces out of there, and I'm going to, I think I'll write this out. There were essentially 4 parts here. We had the x squared in the corner. We had 3x next to it. We had 2x on the lower side, and then we had 6 at the bottom. And what I did is I combined the x's that were the same. I combined the like terms. That means our answer, so let me just put this, the answer is that area. That's really important. Okay, so our final answer, if I ask you, hey, what does this equal? You will tell me it is x squared plus 5x plus 6. This is the answer. We had a 2-piece times a 2-piece. These are called binomials. And then we got this beautiful 1, 2, 3-piece answer. We have a trinomial. And it has a little squared on it. So this thing is a quadratic trinomial. Why try? Because it has 1, 2, 3 pieces. Okay, so we did our math problem and we ended up with this lovely quadratic trinomial. That's what this thing is called. Quadratic because it has a square in it, and trinomial because it has 3 pieces. All right, let's do another one. So we're going to multiply quantity 1 plus 4 times the quantity x plus 1 times the quantity x plus 4. My brain seems to mix things up sometimes. All right, so we're going to multiply the quantity of x plus 1 times the quantity of x plus 4. Tidy that up. I'm going to set up my horizontal and my vertical. This is my place where I'm going to do my problem. Along one side, I'm going to put x plus 1. And it doesn't matter which side you put them on. I tend to use this one along the vertical side and this one along the horizontal side, but it doesn't matter. So we have x plus 1, that's a binomial, 2 parts, and then we have x plus 4. And what do I want to know? I want to know what's inside. What's going to fill this rectangle perfectly? What is the area of a rectangle that has these sides? So I'm going to put my x squared in the corner. That's going to fill in nicely there. These are going to fill in nicely up there. Perfectly filled in, right? Now, ooh, can I fit one of these, right? Almost fits, but not quite. Okay, so that's not going to work. What is going to fit down here is these ones perfectly. You'll see a square is usually going to fit up in this corner. And then the x's are kind of 2 different places. And then we have our little constant in the bottom right. Okay. So yeah, you guys need to learn how to copy and paste for this assignment, because I want to see that you actually built it. Okay, so did I build it? Yes. Okay, now what do I need to do? Now I need to look at my answer. And we know our answer. I'm going to go a little bit semi-concrete. And that is, I'm going to draw what I have. Okay, it's not a perfect drawing, but this is what's inside here. And I have 4 parts. I have the x squared. I have the 4x. I have the 1x, and I have 4. And to finish the problem, we combine the like terms. So there were a total of 5 x pieces. And that's the answer. We took these 2 binomials, we multiplied them, and our answer is this lovely quadratic trinomial. Here's another one. Let's use our algebra tiles. We got the quantity of x minus 3 times the quantity of x minus 3. These back. So I'm going to build x. How do I do minus 3? I'm not going to use these. I'm going to use the opposite of those. So I'm going to go over here and grab these. See how all of these are the opposite of the other pieces? So that's x minus 3 along one side. And then along the other side, I'm also going to do x minus 3. That's interesting. What kind of special shape is this? Both sides are the same. All right, let's fill it in. And this is x times -1. That's like take the x and flip it over. So these are going to actually be negative x's filled in beautifully. And then here I also have x times -1. So those are going to fill in really nicely right there. And then in this beautiful little square corner, we're going to need a -1 times a -1. And what is a negative times a negative? Or what's the -1 and its opposite? It's going to go back to positive. So in this beautiful little corner where we put our constants, we have this lovely square. And how many are in there? Exactly 9. Okay, so here is our original problem. We had x minus 3 times the quantity x minus 3. And we can see that this shape, it's a square, isn't it? It's a perfect, awesome looking square. So I think I'll copy and paste that on there. That's what it looks like. So this one's kind of special. We can write it. We can actually write this as x minus 3 squared. And you can see that this shape right here is a square. Hey, it's a square. It's a square. Yay for squares. Okay. And what do we want? We want the answer. So I think I'm going to draw that out again. We had the x squared in the top. That was because we did x times x. Okay, and then we had 3 red ones. I should probably change colors. And then we had 3 red ones the other way. Sometimes I just put a negative in these, and then I know that they're the opposite. And then I had a beautiful little square made of 9 squares. Okay, so I had 9 yellow ones in the corner. So this is my x squared, and this is just 9 little guys. So what's the answer? The answer is x squared. We have minus 3x, we have another minus 3x, and we had a 9 for the constant. Okay, the final answer here is that we had x squared, we have 6 x's, and they're red, so they're negative, and we have 9 for our constant. That's the answer. Okay, another one. X minus 2 times x, the quantity, this binomial x minus 2 times this binomial x minus 1. Let's get creative here. Delete, 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 delete. It's weird what it deletes. It's kind of like a glitch, I think. Okay, so we had, what did we have? We had x minus 2 and x minus 1. So I'm going to do x minus 2 along this side, just being slightly lazy here, and x minus 1 along this side. And I drag that over. X minus 2 times the quantity x minus 1. I'm going to fill that in. And even though that fits there, this can't be x. It has to be the opposite of x. So that is going to get deleted. And I need this one instead. So x times -1 is negative x. Same thing over here. I need some negatives. I can copy that down. And then -1 times -1. What's going to fit right here? Positive 1. Because -1 times -1 is positive 1. That is what it looks like when you multiply x minus 2 times x minus 1. And then if I want the answer, I have to see what the area is. And inside here, we have 4 parts. We have, I'm going to do it this way just for people who are paying attention. Okay, we have x times x is one of our parts. Okay, we have x times -1 is another part. And I'll draw that. That's a squared. Okay, and then we had a red one. And then over here we had x times -2. So we had x times -2. And then in the corner we had -1 times -2. Over here we had -1 times -2 right in there. And that became, these were negative. And I had these two little guys in the corner. Okay, so the final answer here is we had the squared. We had 3 red x's, -3x, and we had 2. That's the answer to this problem. 2 is my constant. This is the answer. These are the 4 pieces that get put together. We get to put these terms together because they're alike. All right, here's a challenge, and I think I'll have to split this video. So in order to build this one, we would do, I'm going to tidy up. This is a British tool. You know, for 2 reasons. One, it says maths with an S, and the other is it says tidy up a little bit. So we had 2x. See what I had here? 2x minus 1 and times x minus 5. 2x minus 1 and x minus 5. If you practice these, you can get pretty fast at it. Okay, and I want to fill in. Oh, check this out. Look, those 2 fit in there. And then we have, wow, a lot of these. Boom, 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 boom. And then we have more of them in the second row because we have 2 rows. Because we had 2 x's. Okay, down here, one of these is going to fit. And then we have -1 times -5. That's going to be +5. Boom, boom. There it is. And I gotta go to class, so you can finish that one. It's a challenge. You can think it through. Good job. Talk later. Bye.